In this video, I will show you how to do transformations with piecewise functions. So we've learned that different changes in the equation will have different effects on a graph. For example, here's some notes. It's easy to see using a square root function, but it works the same for all functions. If you have a negative sign in the front, that's a reflection over the x-axis. This a value, picture this being a 3 or a 1/3. This a value is going to be a vertical stretch if it's bigger than 1, or a vertical compression if it's less than 1. If you have a negative sign inside the function, that's a reflection over the y-axis. If you have a b value right here, that's going to be either a horizontal stretch or a horizontal compression. It's the opposite of what you would think. If this b value is less than 1, that's when it's a stretch. If the b value is greater than 1, that's when it's a compression. And the h value is going to be a left or right motion. And that's the opposite of the way it looks. If it's positive, it will be left. If it's negative, it will be to the right. And finally, if you have a k value, that's going to shift the graph either up or down. And this one's normal. It will shift the graph up if it's positive and down if it's negative. And again, that works for any type of function. So it should work even for a piecewise function. So this graph is the original function f of x. Now we are to graph g of x, which is has several transformations of the original function f of x. So we're just going to graph them one by one. Let's start by graphing function g that represents the following two transformations of function f. We have this vertical compression by a factor of 0.25, which, by the way, of course, this is the same thing as 1/4. And it is shifted up 4. Notice that both of these are vertical changes. We have a vertical compression, so it's vertically getting shorter, and we have this vertical shift of up 4. Because everything is so vertical, that means everything we do, we will be doing it to y values. Let's make a list of the critical values from the original function. So looking at the original function, look at all of the endpoints, and let's record the coordinates of them. So this first point is the point -6, positive 6. Notice that they're counting by 2s. 2, 4, 6. -2, -4, -6. So this is the point -6, 6. Let's write that down. -6, 6. All right, next let's do this open circle down here. This is the point -2, -4. Again, they're counting by 2s. So -2, -4. All right, how about this point right here? This is the point -2, 1. See how it's halfway up? So that's a 1. So -2, 1. Okay. Next will be this point over here. This is the point 6, -1. So that's a critical value, 6, -1. And last, we have this open circle right here. This is the point 6, 4. 6, 4. So these are all of the endpoints of the original function. So what we need to do is we need to find the new y values. So I'm going to make a third column. Okay, now this f of x is basically like a y. So what we're doing is we're multiplying 0.25 times every y value, and we're adding 4. So that's what's going to go in this column. It's going to be 0.25 times the y value plus 4. All right, that's what this equation is really saying. So, for example, if I do 0.25 times 6, and then I add 4, I'm going to get 5.5. Okay? So I'm simply substituting each y value into this expression, and I'm going to see what I get. I'm going to go ahead and do that with all of these values off camera. Alright, so basically I'm doing the vertical compression and the shift up 4. I'm doing both of those things at once by taking each y value and multiplying by 0.25 and adding 4. Okay, that will give me a vertical compression by a factor of 0.25 and a vertical shift of up 4. So these are my new y values. So I can throw out the old y values. They're gone. Okay, nothing is happening to the x values. We just had a vertical compression and a vertical shift. Nothing horizontal is happening, so none of the x values will change. So these will be the coordinates of the critical values after these transformations. So I'm just going to plot them. So the point -6, 5.5. Okay, so here's -6. 5.5 will be right here. And I believe this first point was a closed circle, so I have to keep track of that. The next point is an open circle, so be careful. So I have -2, 3. So here's -2, 3. This will be an open circle. So this piece of the graph is going to look like that. Okay, the next point is a closed circle. So -2, 4.25. That is a closed circle. All right, and the next point is also a closed circle. Okay, so that's going to be 6, 3.75. So 6, 3.75 would be about here. So I'm going to draw that segment. Right, these are far apart. So I've got to be a little extra careful. So there's that segment. Okay. Now, the last point is an open circle. So this is going to be 6, 5. So 6, 5 is an open circle. And this last piece is a horizontal line going to the right. Okay, so this is what the function would look like after we did these two transformations. So here's the first answer. The next function is almost the same thing. Again, we are doing a vertical stretch, and again we are doing a vertical shift. So this is a vertical stretch by a factor of 3 and a shift down 6. So again, both of these changes are only affecting the y values. So I'm just going to need a new y column. I just copied the same points. We're just transforming the same graph over and over again. So we're going back to this graph every time. So now that I've made myself a nice list, for the remaining 3 problems, I can just copy the list over. And I also went ahead and took note of which points were closed circles and which were open circles based on the previous problem. So I don't have to keep scrolling back and forth just to see if they're open or closed. Okay, so we're making a new y column. And the new y column will be 3 times the old y value minus 6. This will accomplish the vertical shift, the vertical stretch, because I'm multiplying by 3, the y values by 3, and it will achieve the vertical shift of down 6 because I'm subtracting 6 from the y value. That will move you down 6. So for example, if I substitute in the y value of 6, that's 3 times 6 is 18. 18 minus 6 is 12. So this will be 12. And I will do a similar calculation all the way down. So these are my new y values. So with that, I can throw out the old y values and plot these key points. So the first point is negative 6 comma 12. Some of these points are off the graph, so I'm just going to do the best I can. So negative 6 comma 9, 10, 11, 12. Alright, let's just say it's going to be about here. Then negative 2 comma negative 18. Wow. So here's negative 2, and here's negative 9. So negative 18 is going to be like way down here somewhere. Who wrote this problem? Man, this is ridiculous. Alright, I'm going to have to scroll out. Okay, so obviously this is ridiculous, but this segment would look something like this. Nowhere near fitting on this graph, so I apologize. But let's move on to the next segment. Our next key value is negative 2, negative 3. These endpoints will both be closed circles, so negative 2, negative 3 is right here, and it'll be a closed circle. Okay, and then we have the point 6 comma negative 9, and that will also be a closed circle. So 6, negative 9, closed circle. Okay, so at least that segment fit on the graph. And the final key value is at 6 comma 6, and that is an open circle. So 6 comma 6 would be right here. It would be an open circle, and again this was a horizontal line going to the right, so I'm just going to go ahead and make that horizontal line going to the right. So even though this one piece went way off the graph, this is basically what this function would look like. Alright, this function with its transformations will be similar but different than the previous two problems. The previous two problems, the transformations only affected the y values. This time the x values will be affected because of this negative 5. Now, when you have something being added or subtracted inside the function, that is a horizontal shift. Horizontal means x values. Now be careful, this is actually a shift to the right 5. So it's the opposite of the way it looks, and that's going to affect what we do to these x values. And this is, of course, up 3. Up 3, that's vertical, that's going to affect the y values. So we will need a new y column. Okay, and my new y column is going to be y plus 3. We're just going to do the up 3 part. So we're just going to add 3 to all of these y values. But we will also need a new x column as well. Okay, now because we are shifting to the right 5, our new x column will be the old x values plus 5. So even though there's a minus 5 sitting here in the formula, to move right 5, we have to add 5 to all of these. So by the way, just in case you skipped directly to this problem and you didn't watch all the previous problems, we are supposed to be transforming this original function using these transformations. So what I've done is I've copied the coordinates of all of these key points, these 5 key values. For example, this point is negative 6 comma 6, and so that's why I have a negative 6 comma 6 right here. So here are those 5 key values. Now I'm doing the transformations. So for example, if I substitute in 6 for y, so I'm just adding 3, so that this is going to become 9, and this is going to become negative 1, and this will be 4, and this will be 2, and this will be 7. So I simply added 3 to all of these y values. Similarly, I need to add 5 to all of these x values. So this will become negative 1, and 3 again, and 11, and 11 again. So now that I have these new y values and the new x values, I can throw out the old x values and y values. So I will be plotting these points. Now, notice that on a previous problem, I sort of recorded which points are open and which were closed based on how they looked in the original picture. Okay, so let's just copy that over again. Closed, open, closed, closed, open. Not there. So this will be closed, open, closed, closed, open. So my first key point is negative 1 comma 9. So that's going to be right here, and it is a closed circle. The other end of that segment is at 3 comma negative 1. So 3 comma negative 1, open circle. So we'll just connect these up. These are pretty far away. It makes me want to cheat and use my line drawing tool. Okay, that's pretty good. Now the next segment has closed circles on either end. 3 comma 4. So here's 3 comma 4, closed circle. And then 11 comma 2. So this is going to be off the grid a little bit. So this would be like 10, 11 would be about here. So 11 comma 2 would be about here. Okay. Okay, got a little janky in the middle there, but you get the idea. And then the final key value is at 11 comma 7. So that's going to be about here. This one is an open circle. And we have seen that this is always an arrow just going to the right. So this will be just a horizontal line going to the right. Okay, so that is how you would do this transformation of the piecewise function. All right, let's do one more. Okay, now we are going to do this transformation. Now, as I do the transformations shown here, I'm going to need you to ignore this red piece of a graph that's coming into the middle of the graph paper. I had a previous problem where the numbers just got crazy, and I mean, this segment is 30 units long, so it is stretching way down into this graph, but this is the answer key that I'm making, so I don't want to erase it. So what I'm going to do is I will do this graph in green, so just ignore the red and focus on the green. So once again, I have copied the list of the critical points from the original function shown here. Alright, and I've copied the 5 critical values. So for example, this point right here is the point 6 comma 4, and if you look at my little list, you'll see the point 6 comma 4 right here. So I've copied all the critical values. Okay, so I have these 2 transformations. This is, well, technically it's 3. I have a reflection over the x-axis, a vertical stretch by a factor of 2, and a shift up 1. All 3 of these transformations only affect the y value. So basically we are going to have to make a new y column. We will not need a new x column. Alright, nothing is happening horizontal. Okay, so the new y column, remember this f of x is basically just a y. So we're doing -2 times y plus 1. That's how we will get our new y values. We will do -2 times y plus 1. Okay, so for example, -2 times 6, that's -12, plus 1 is -11. -2 times -4, that's 8, plus 1 is 9. -2 times 1 is -2, plus 1 is -1. -2 times -1 is +2, plus 1 is 3. -2 times 4 is -8, plus 1 is -7. So these are the new y values. So now that I have my new y values, I can throw out the old y values. By multiplying by -2, this is accomplishing the reflection over the x-axis and the vertical stretch by a factor of 2. It's doing both of those things at once. And then when I add the 1, wait, I didn't add 1. I did add 1. By adding the 1, I'm shifting all of the points up 1. So that's all I have to do. So I'm just going to plot these points. As I plot the points, I have been memorizing which points are open circles and which points were closed circles. So it went closed, open, closed, closed, open. So I'm just going to copy that here. So it was closed, open, closed, closed, open. Alright, so we have the point -6 comma -11. Alright, so -6 comma -11. So this is -9, -10, -11 would be about here. Okay, and I think we said it was closed. Alright, -6, -11. Then I have -2, 9 is the other end of this segment. Like basically this is a segment right here. So -2 comma 9. So -2 comma 9 is right here. And this is an open circle. So can I even fit these on the screen at one time? These are so far apart, I'm going to cheat and use my line drawing tool, because I know I'm just going to miss if I try to do it by hand. Okay, let's see if I can make it green at least, so it matches my other white. Okay, there we go. Again, ignore the red. That was part of a previous problem that got out of hand. So there's the first segment. Now let's do the next segment. Alright, both endpoints are closed circles, but I've got -2, -1. So -2, -1, so I've got the closed circle right here. And then I've got 6 comma 3. So 6 comma 3, another closed circle right here. Okay, I'm going to try to do this one by hand, maybe. Okay, so that's the second piece of the piecewise function. And now the last piece, the endpoint, open circle, is 6 comma negative 7. So 6 comma negative 7 is here, open circle. And this one is always a horizontal line going to the right. Okay, so this is what the piecewise function would look like. Again, ignore the red, just the green. Under the two transformations, well, the three transformations, really. Reflection over the x-axis, vertical stretch by a factor of 2, and vertical shift up 1. Kabam! Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.